Good afternoon. Now that everyone is half asleep from lunch, I'm going to take you the rest of the way. I'll be talking about the physical map revision in Churchill County. Actually, this is the Carson River below Lahontan Dam. So the outline for this presentation is I'm going to talk a little bit about the flood map revision process, talk a little bit about the different kinds of map revisions that you can have and how that impacts the project. We always get a lot of questions on timing and approach, and the type of study you're doing can impact all those factors. Talk about the project location, the hydrology. We have some revised hydrology below Lahontan. Then a little bit about the modeling that we did, and then the revised mapping. So the FEMA, there are a few different processes by which FEMA revises maps. And there are essentially a flood insurance study. Most of you have probably heard of the flood insurance studies. That's a FEMA initiated process. The communities put in an application for a revision to their floodplain, and then FEMA rates these applications based on a cost benefit, and then FEMA initiates and manages the contract. So FEMA is hiring the contractors, FEMA is managing the product, managing the project, and there are a limited number of these each year. So that's one way a community can get its maps revised. The other process is what the Carson Water Subconservancy District is going through, and it's the CTP, or Cooperating Technical Partner Program. This is a community-initiated map revision, and this is funded by FEMA, but it is initiated and coordinated by the community, or a cooperating technical partner. This is something that an agency like the CWSD can put in for and become a technical partner. In that way, the community is the one managing the work. They're using local resources, in theory, to do the work, and they're getting a lot more feedback from the community. It's a grant-based funding mechanism. So they're getting a lot of outreach, a lot of interaction, a lot of stakeholder. The FEMA process is sort of handed down from the federal side of things, and they can pick whatever contractors they want to do the work. So the different types of map revisions that we hear about are what I talked about, the flood insurance study. That's managed by FEMA. It's usually a larger scale. The physical map revision is a community managed, or it's FEMA funded but community managed. And it typically involves many different map panels. So you're remapping a bunch of map panels. And then you've probably heard of the letter of map revision. That's more of that's managed by a local entity or a private party. It's not funded by FEMA. And it's typically a smaller scale. And there's a different process and a different time frame for all of these different map revision types. So we're going to be talking about the physical map revision, because that's what the Carson Water Subconservancy is initiating or going through right now. So the project location is below Lahontan Dam, and it's approximately 30 miles of the Carson River below Lahontan. And you can see in the graphic here, we're ending it right around Tarzan Road, if people are familiar with that area. It's not going to be remapping through the city of Fallon, but it will be the Carson River. And I should note that this concludes a 8 or 9 year effort remapping the entire Carson River. So this is the conclusion from Alpine County down to below Lahontan. This will be the conclusion of remapping the Carson River. So I'll talk a little bit about the hydrology, so the amount of water that we're talking about in this reach. The effective flood insurance study, or what's currently the 100-year flow, is based on a 1993 estimate in the area. And that was considering the dam operations of the 70s and 80s. So they weren't looking at current operations of the Lahontan Reservoir. And that has a huge impact on the floodplain and the flood flows below the reservoir. So we went through a process to revise the hydrology. And Precision Water Engineering was the one that did the revised hydrology. And what they did is they took 109 years of flow records above Lahontan, and they routed them through the dam with today's current operating procedures. So if those daily flows were run through for the last 109 years through the reservoir as it operates currently, what would the outflow look like? And then they took those annual peak outflows with the revised operations and did a statistical analysis on that data. So it's more of an up-to-date, they're taking historic data and revising it to match current operating procedures. And so the revisions to the hydrology, you can see here, the original flood insurance study saw about a 3,600 CFS flow downstream of Lahontan. Our revised hydrology shows about 3,300. So it's not a huge change right below Lahontan. During 2017, if everyone remembers, it was one of the wettest years on records. And flooding below a reservoir like this is more driven by volume in the watershed and the amount of snow melt that comes out of the mountains, and less about a particular storm event, because the reservoir is storing water. But if you get these immense amounts of volume, they have to start releasing that water. So in 2017, there was a lot of pressure to release water into Churchill County. And so there were major diversions at the Carson Diversion Dam. And they were able to split 1,900 CFS off at the Carson Diversion. The flow coming out of the reservoir at that time was about the 100-year flow. It was very close to 3,300 CFS. And that amount of flow would be a problem for the areas below the diversion for Fallon. So if you look at this graph or the table here, so at Highway 50, the original study for the flood insurance study didn't consider this diversion. And it was a higher flow coming out of the reservoir. So our revised hydrology at Route 50 is about 1,400 CFS versus the 3,300, or versus the 3,100 that was in the original study. So you can see a big reduction in the flows below that Carson diversion. And that becomes a really important feature in managing the floodplain below that diversion. TCID was able to release 1,900 CFS in 2017. And that was part of, I don't know if you've heard of the Big Dig project, where they diverted flow out of the Carson River and into the sink just south of the river. They were able to bring those flows down to a really manageable level. So this really factored into our study and the mapping, as you'll see. So this is kind of the revised hydrologic regime below the reservoir. You can see that our new estimate of 3,300 is coming out of the reservoir. You have the Carson diversion, which is diverting to the T and B line. And that's about 1,900 combined. There is also a commitment to divert about 190 at the Coleman diversion, CFS, and then about 70 at the Seguski Dam. So TCID is actively managing these diversions during a high flow event to try and shed that water away from the river and the folks that live along the river, the properties along the river. So just to give you some kind of a scale on what the reservoir Lahontan does, the 1% or 100-year flow above the reservoir is 36,000 CFS. The 1% revised flow or 100-year flow below the reservoir is 3,300. So you're talking about an order of magnitude difference due to that reservoir storing all that water coming through the Carson River. So you have a very, very different floodplain downstream of the reservoir, and it's managed much differently because the outflows are metered. They're not directly driven by a storm event like 97 or 86. It's more about the volume of water in the reservoir and how that's released. And then below the Carson diversion, again, we have 1,400. So you're looking at, some areas of this floodplain having a 1,400 CFS 100-year flow versus above the reservoir at 36,000. And I'm going to show you a graphic here. Just for my own curiosity as a hydraulic engineer, I took that 36,000 CFS above the reservoir and ran that through our models below the reservoir, and to see what would happen in Fallon if Lahontan didn't exist, for instance. And it turns out you send about 10,000 CFS right through Fallon. And here's kind of a graphic of what the floodplain would look like downstream of Lahontan without the reservoir. So the blue is the 36,000 CFS floodplain. The black is our revised floodplain with 3,600 or 3,300 and then 14. So it is a very different picture below Lahontan without that reservoir in place. And again, you can see where about 10,000 CFS goes to the southeast into Fallon. Just, as a curiosity in my twisted brain. So I'm going to talk a little bit about the hydraulics, how we did the modeling. We used HEC RAS, which is a U.S. Army Corps of Engineers product. And why we chose that, it's a public domain software. So it's free, it's available to everyone, it's not proprietary. It's been extensively tested by the federal agency. It's very computationally efficient. They've done a lot of work on this software to really improve its computational efficiency. It's upwardly compatible, so you can take older studies and use the newer versions of the software and vice versa. It's also accepted by FEMA. And because it's so rigorously tested, not all softwares are accepted by FEMA as a resource to use for hydraulic modeling for these flood studies. There are only a handful of hydraulic models that are available and that FEMA will accept. And this one is so extensively tested that they have an agreement with FEMA that as the new versions come out, they don't need testing. They are automatically accepted by FEMA for flood studies. So using this software, we're always assured that FEMA will accept the results of our study. So it's for this particular study, we are using what we call a one-dimensional steady state model. So when we talk about a one-dimensional model, it is a series of cross sections down the stream reach, which hydraulics are computed at these cross sections. Now this is different from a two-dimensional model, which is kind of an area grid, and water can move in 2 dimensions. Water is only moving in 1 dimension. This was chosen because this reach of the river is fairly well confined. You don't have a lot of flow splits or floodplain overbank flows, especially with those reduced flows out of Lahontan. So the geometry that we used is based on a 2019 Bureau of Reclamation LIDAR information or terrain information. So it's very up-to-date terrain information from 2019. We had approximately 523 cross sections that will represent the floodplain from the dam down to Tarzan Road. And it's a 30-mile reach. So we modeled those flows through this 30-mile reach. And again, I talked about those various diversions. So we did flow changes at those various diversions to simulate the 100-year flood. We also went through a floodway analysis per FEMA's regulation to look at if you encroached on that floodplain, how much encroachment could you have before your water surfaces come up a foot. And that's a standardized FEMA approach that we went through for that. So we are going to be remapping the floodplain and floodway, if folks are familiar with the floodway concept. So this is just kind of a picture of the actual model itself. Each one of these cross sections is, hydraulics are computed at each cross section, and it looks downstream and upstream to the next cross section and performs what we call a step backwater calculation to compute what the water surfaces are for each of these sections up and down the reach. So this is the methodology that we're using for this study. Now this is different from the Carson Valley, for instance, where you have bifurcated flow going all over that valley. We needed to use a two-dimensional model for that reach of the river. This was much more straightforward hydraulically. So it lent itself more to this type of an analysis. So I'll talk a little bit about the mapping that's coming out of this study. I can show you, this is the existing mapping right now. And you can see that the Lahontan is at the far left of the screen here. This whole area that you're seeing in light green was what we call an approximate zone A. So there's no information, it's done with approximate methods. There's no information on water surfaces. So you can't set finished floors. You can't look at studies, you can't look at adjacent properties. It's a very approximate study. And if any work is to be done in that area, the person doing that work, the onus is on them to create that data. So they need to do their own study to develop water surfaces before you can do any development or anything like that. The darker blue going down is what we call a detailed study reach. This is the current flood map. And so there was a detailed study reach for the area through Fallon. You can see the light blue is the 100-year floodplain. Through that area, the dark blue is the 500-year floodplain. And then at the very end of the map here, you have, again, an approximate reach. So this is kind of a mismatch of floodplain designations. We took the model and we revised with the new hydrology and the hydraulics model. We're doing a detailed study from the reservoir all the way to the end of this map here. So when the revised maps are published, you'll have water surface information throughout the whole reach. It won't be this approximate study, this approximate reach. And I can kind of show you that new mapping. We're going to have zones A, E, and we're going to have an AE floodway developed in this area. There will be consistency in the mapping, no more approximate. It's an updated, the current maps are from the 70s and 80s. And it's, that was outdated technology, outdated modeling, outdated topo. We updated the terrain to be 2019. The methodology is much more robust. The hydrology is revised. It's a completely different study that's more representative of the conditions that exist today. And I can kind of show you, if you remember back from the previous study. So the darker blue in this picture, and I know it's hard to see, that darker blue was basically the 100-year floodplain in the existing study. That's now the 500-year. So the floodplain widths were much reduced in this study. The lighter blue is the 100-year, or the 1%. And then the floodway is the hatched, almost imperceptible at this scale. So with those reduced flows and that diversion at the Carson diversion, the flood maps are very much different than what was previously mapped downstream of that study. And TCID has agreed that if those levels of flow come out of the the reservoir again, they are committed to doing that diversion, to making that level of diversion to protect, Fallon and the downstream, residents and facilities and stuff. That is part of the FEMA. If you're going to consider diversions in your FEMA study, FEMA requires that you have an operation plan and that there is a responsible party with signatories and the whole 9 yards. That goes into the record of the mapping, because if they don't perform that diversion, it completely negates the mapping downstream of that diversion. So we've gotten TCID to commit to that kind of flood fighting, flood management approach with that diversion. And that's the only way we can map it like this, is with that commitment to that flood fighting, that diversion. So where are we now? All the data has been submitted to FEMA and the MIP. I just saw Debbie cringe a little bit. The digital data has been submitted. The modeling and mapping is to be reviewed by FEMA. So that's kind of where we're at right now, is that FEMA is going to review the modeling and the mapping that we did and provide feedback to us. Then there will be a comment and response period. So we have an opportunity to respond to FEMA's comments and questions. And then there will be a 90-day public comment period. So then the public has access to our proposed maps, and they can make comments, the local stakeholders and the public can make comments to FEMA about the mapping. And then they'll finalize that mapping after that comment and response public period. I will say that this is probably the only study I've ever been involved in where people were happy about the outcome. Probably the only one I've ever known about that people were actually happy about the outcome, the downstream. Usually there's a lot of grumbling when the floodplains change and the flood maps change until the dust settles. So that's all I have for this study. I don't know if anyone has any questions.